The architectural rendering shows a mobilization of massive scale, yet the site's apparent readiness masks a deeper operational stall. This reporting cutoff identifies 30 isolated evidence items as the true drivers of the project, superseding the visible activity on site. The current schedule contains a critical date ambiguity. The foundational board pile phase is trapped between the 22nd and the 29th of August, leaving the critical path without a committed start date. We maintain a strict definition of progress. A status is only green when we have an accountable owner, a current data date, physical acceptance evidence, and a verified closeout. Reporting 92 workers and 14,000 safe man-hours can obscure the reality of a blocked workfront. Physical presence does not equate to a released work zone. In mission-critical construction, unverified assumptions and narrative updates act as liabilities. We require objective proof of readiness to proceed safely. Phase 1 civil works and late-stage Level 5 integrated systems testing function as a single connected dependency loop. A delay in the foundation inevitably impacts the final testing sequence. We use the Connective Insight framework to map relationships between every layer. The board pile node is restricted. Unresolved engineering and utilities prevent substructure release. These vertical dependencies are rigid. Civil foundations dictate MEP pathways, determining installation windows for long lead chillers and generators. Mapping the commissioning Level 0 system boundaries now is a technical requirement. Missing this step leads to integration failure during final handover. Our first requirement is a frozen Phase 1 logistics plan. We must establish color-coded zones to separate personnel access from heavy plant operations and utility trenches. While 28 plant units are on site, they cannot be utilized without pre-use certification and signed operator release forms. Physical availability is useless without technical clearance. The foundational concrete works are currently held at the trial mix acceptance gate. Every pile poured depends on a verified quality record. The concrete mix must achieve a verified 7-day average of 28.49 megapascals to pass this gate. The reconciliation protocol ensures that digital batch records align perfectly with physical delivery tickets, sample IDs, and temperature controls before production starts. Physical mobilization only provides value when it is backed by an unbroken chain of traceable quality documentation. Planned piling zones intersect with existing subsurface utilities. We must clear the water, electrical, and gas corridors before the drilling rigs can mobilize. The water and electrical lines have progressed, but the gas pipe relocation remains an unresolved critical blocker. Resolving this interface requires authority permits, pressure testing, and a confirmed plan for service continuity and reinstatement. Managing high-risk utility interfaces requires active permit-to-work records and field-verified isolations to maintain our zero-incident status. The project schedule is speculative until these utility interfaces are physically signed off and cleared from the critical path. Beyond the physical constraints, an administrative bottleneck is currently dictating the project's pace. The engineering register shows 39 first submissions logged. Material requests and shop drawings are waiting for a response, with 0 replies recorded from the design team. We have 10 unresolved RFIs. These knowledge gaps act as hard blocks, preventing the formal release of new workfronts. To clear this backlog, we must assign construction need dates to every submission. This forces the design team to prioritize technical reviews based on the critical path. Technical errors on paper create structural failures in the field. Every drawing must be verified before the first pile is drilled. A verified CXL0 package is the baseline for all MEP systems. It requires approved system boundaries, redundancy philosophies, and a locked asset tag schedule. Accurate thermal mapping dictates our mechanical loads. We must finalize the chilled water loop design before the primary structural penetrations are set. Power infrastructure requires the same level of foresight. Medium voltage switchboards and UPS systems need precise builder's work provisions, from earthing points to structural plinths. Digital control layers must be locked down early. We are finalizing input-output schedules and sequence of operation flowcharts before the physical installation begins. The mechanical fuel system serves as a specific case study for this interface management. Civil trenches and generator plinths are held until the fuel system's autonomy calculations and hazardous area reviews are locked at CXL0.
We must avoid the risk of bypassing technical design approvals simply to hit a vendor's manufacturing date. Bypassing these gates leads to digital integration failure, where a chiller passes its physical factory test but cannot communicate with the building management platform on site. Structural edge cases require early verification. For example, the EOT crane requires rail and anchor load validation against the primary civil frame before we can finalize the structure. These misalignments are often caused by parallel reporting structures that issue conflicting instructions to the field teams. Eliminating this confusion requires a single RACI matrix, a unified document control route, and delegated authority signed off by the project director.
The Week 3 valuation confirms the site is physically prepared, but remains restricted by unresolved engineering, utility, and CXL0 data. We are moving into a period of active management, closing every release gate through digital signatures and verified physical stamps. The mandates for Week 4 are non-negotiable. Reconcile the quality dossier, clear the utility interfaces, recover engineering replies, and approve the MEP system governance. These completed actions will allow us to finally lock in a confirmed critical path start date of August 29th. Reliability in a data center environment is the direct result of the exhaustive technical documentation that confirms every system meets its design intent.